All right, welcome everybody to the weekly study session of how to program smart contract on Bitcoin. And today we are going to cover the, kind of like a standard libraries, which we call the buildings. So there are two types of buildings here. So before we even dive into the details, so here, why do we even have this? It's like many other either languages or libraries or frameworks. So basically, once you know how the syntax, you can pretty much write anything you want. But in reality, there's a lot of, you don't want to write everything from scratch. So we provide out of the box a lot of functions or contracts you would use anyway, right? So we just wrap this up and ship it with by default with the ScriptTS library. So you don't have to write all from scratch. Okay. So there are two, I would say there are three big categories in script right now. So first one is so-called global functions. So this one is by the definition, right? You can use it whenever you import script, you can just use it anywhere you want. And it's not bounded to a specific library or contract. You can use it anywhere, right? So far, I think we have all seen this assert. So basically, this is the way, the primary way you check whether your contract is working as expected. So basically, you give it like a Boolean condition and you check whether it make sure this condition is met. Okay. So if not, it will throw. Okay. So we have seen this already, time and time again in public, especially in public methods. Okay. And another one, which is also very handy, I think, fill. I think some of you, if you already play with the array. So here, in our case, you can only use one specific type of array called fixed array. So, a lot of time when you try to initialize it, you just want to give it some, all the elements the same value, right? This is very handy. Basically, it's just the name suggests. It just, if it's, let's say, you put one in an array of three, size 3, you just say, hey, put one in all the 3. Or if you want 3,000, you don't have to write it 3,000. So it's a very like an easy way to initialize an array to the same value, okay? And again, another big type here is so-called math. So a lot of times you want to do some simple math, so we also replicate it. So you don't have to write again from scratch, right? So just simple ones to get to start with, absolute values, min, max, and also there's another within. I think we don't want to, yeah, this simple stuff. So just sometimes it comes handy. You don't have to write. I think another big, very popular category you can see is hashing. So because we're dealing with, anyway, a lot of time we're dealing kind of cryptography. So this is one very primitive building block. It's just different hash functions. So for example, right, people, how many of you have heard about SHA-256? Because that's the hash function used even for Bitcoin mining. So you actually double, do SHA-256 twice. So this also a, simple wrapper, pretty much just called hash 256. Basically, just does it twice. Another one is also very popular, called hash 160. So basically, this is the function. If you know a little bit about Bitcoin address, so this is how you used to convert the public key into a public key hash. So you use this hash function. So basically, also is a mix of these two, RapMD and then SHA-256. And this is SHA-2 family, but then we also have the, for historical reasons, we also have SHA-1. Also put it here, okay? So another big category we always use, this is also often used to, is so-called, we have 3 primitive types, right? Big int, Boolean, and then byte string. And a lot of times you want to convert between, for example, byte string and big int. So you call this back and first, right? If you want to convert big int to a number, no, sorry. If you want to convert a big int to byte string, you call this. Otherwise, you call this. Okay. So the only thing you have to pay attention here is because in Bitcoin, we don't use a two's complement. So it's called a sign magnitude. So this encoding is a little bit of a, I would say, unconventional. So you have to pay attention to when you actually look at the hex or binary format, you have to using this encoding to convert it to numbers. Okay. Any of you heard about this before? Sign magnitude encoding versus two's complement.
Yeah.
Okay. Yeah, it's kind of so basically when you have signed numbers, right? Especially when you have let's say negative numbers, how do you represent it in binary, right? So if you're using the textbook, I think most system use so-called two's complement, and then you have another alternative called sign magnitude. Basically, is if you the most significant bit is 1, that means it's negative. Otherwise, is non-negative. Okay. So just yeah, if you don't know, just click this link. It will just show you examples. You should get it. Okay. Also, you can get the length of the byte string, and this one is also very popular. Basically, a lot of times you have different endings, within the system, right? For example, here, when you encode the numbers, it's in little ending. But if you some other part, for example, if I recall the signature part, so you have the different components, the R and S, if you for ECD as a signature. So they are big ending. So basically, short story is, this is typically used when you have different endings and you want to convert between the endings by reverse them bytewise. So you call this function. Okay. So this is all like very handy. Yeah. And then the next big category is this one. So if you remember when we try to write contracts, we have a lot of operators. So, if we go back, let's say we have a lot of operators you can always use, right? For example, add, subtraction, multiply, equal, smaller, then, all this. But you notice there's something is missing here. It's so-called, bitwise operations. For example, you want to do bitwise AND, or, the reason we don't overload here is here you can only think about, we just reuse the operator from TypeScript, right? But here, the primary reason here is because of we use different encoding. So some of them is not consistent. For example, if you do like invert on two numbers, invert in Bitcoin system versus invert the bit in TypeScript, sometimes it's not consistent. So that's why we choose not to overload to reuse the operator, because otherwise it would be confusing, right? Because for example, you invert some number in TypeScript, it gives you X, but if you invert the same within Bitcoin system, it gives you X prime, and these two are not the same. So this is very confusing. So that's why we use use the function form. Basically, if you want to AND, like bitwise AND these two, instead of using Amston or the usual operator, you use a function call. Okay, because always remember, whenever you do this bitwise operation, first always convert. This number is always convert to so-called byte string first, and then do the operation, and then come back. Okay. So you always use the so-called sign magnitude little ending. So this is how it works internally. So that's another, that's what I'm saying. You use the function form to avoid, because sometimes it's not consistent with the default TypeScript implementation. Any question about here? Okay, seems you guys got it. Okay, so the last one is also popular, exit. So basically, it's always similar to other languages. Exit, basically, you quit, you finish the running for the whole contract. You just pretty much exit the whole thing. So you can give it a status based on whether it says this, whether when you reach here, whether it's return successful or not. Okay, so you have pretty much exited the whole contract at once. Okay. So this, I just finished the global function part. Hopefully this is easy. So the next we're going to look at some of the, the method within the smart contract base class. So this is the class, if you remember, everything we write derives from this base class. Right? Every smart contract, you have to derive it from here. Okay. So this also has some, very often used methods come with by default, so you don't have to write everything from scratch. So the number one thing I would say most popular is so-called checksig. So this is the way to, in Bitcoin way to check whether a signature matches, a certain a signature, a public key, and a message, they match. So if the signature is valid for this public key against certain message, this will return true. Okay. So for example, in the most famous, I would say popularly used when you send a Bitcoin from Alice to Bob's address, this is so-called a pay to public key hash. So in here, you pass two parameters. One is signature, the other is public key. So basically, if the public key hashes to the address and also the signature is good, then you can successfully unlock the coins here. Okay. So this is the very signature checking is always, I'm not always, is most often you will use this in your contract, because otherwise anybody can interact and may take your money, right? Because if you don't control this, if you got to have some secret value. So usually this is done by the usage of some private key. Okay. Okay. So the next one is also very often used, especially in so-called stateful contract. Previously, we talked about how to write smart stateful contract, right? Basic idea is you use the so-called script context, make sure the new UTXO you create, the code, the smart contract code is the same with the previous UTXO you are spending from. And then you can be sure the state is maintained across a chain of transactions. Okay, so this is the basic idea. So there you often have to, create a output that has a latest state. So, we have this wrapper. Basically, you can call it, this start build state output and give it how many satoshis you're going to be putting in the new output that contains the state. So this is very often used. You're almost always going to use this function whenever you are writing stateful contracts. Okay. So basically, this builds the output contains the latest state in the spending transaction. Okay. Yeah, similarly, there's another one that's also very popular, because a lot of times you're going to, because in the UTXO model, right, is each UTXO is a whole. You can spend the whole thing, or you can spend zero of it. You cannot spend, let's say, 50% of it. So many times, because you want to pay somebody, but you don't have the exact amount, so you have to get back your change. So this is a very handy way you build, the change output. So you just call, build change output. Okay. This is also very often used. Okay. So besides these two, the global functions and smart contract methods, another often used one is this. I think this is the kind of like the highlight of what we are going to cover today. So I think the previous two is pretty easy to understand. So hopefully this one is also be easy for you. I think at least for this one is very, straightforward. So it's a utility library that basically provides a bunch of, smallish but often used utility functions. For example, here, right, you may want to convert, as I said before, right? You may want to have some signed or unsigned numbers, and then you can also have some numbers encoded in little ending, sometimes in big ending. So you use this to convert, the numbers back into some kind of the format you want. For example, right, you want to say, hey, this number is encoded unsigned and also in little ending. I want to convert it to a certain length of byte string, right? You can say, hey, 10, I want to convert the 10 into a 3-byte string, a string of 3 bytes. So this is what you get. Yeah, this is also in little ending, right? So you can tell, right? This is the little ending because the most significant part, the byte, is in the first byte, okay, not in the last, okay. And you can also have some other way, like build output. Basically, you want to build a transaction output. You give it the script part and also the amount part, so you can get the output out of it. And also you can have, let's say, you want to, as I just mentioned in the CheckSig example, sometimes you want to just build a so-called regular output, so-called pay to public key hash. So you can always, this is a very useful, like a shorthand way to build it. You can also construct it manually, but this is just so often, so we just give you your wrapper. So you just give the public hash, and then you can produce the pay to public key hash output. The same for false operator. So basically, sometimes you want to put in some data, just dump data into some unspendable output. There's a lot of times people use this to attach some kind of data and put it on the blockchain. So you can also use this one. You just proceed this with false operator and then whatever comes behind it. Okay. So for example, here you want to inscribe hello world onto the blockchain. So you just call this, and this will build an output. And then you can put this output into your transaction and broadcast it. And then the hello world will show up on chain. Okay. So, okay, let's go to this a little bit complex example here, which is also often used. So if you remember, we have some kind of different data types. So, basic types, but also you have array, but also kind of like a struct like customer defined composite types. But another very often used structure is so kind of like a hash table or some called associative array, and some other language called just map. So it's also it's a key value store. This is also very often used if you done any kind of non-trivial programming. So we also provide this, but the only difference is here is a little bit special because the unique feature of Bitcoin and that's Scrypt. So in most other languages, pretty much all the other languages, when you have a hash map, so basically you have the key and you have pretty much a list of entries, and each entry consists of a key and its associated value, right? But for Bitcoin, if we do this natively, because the key and the value, they can be arbitrary, right? So it can be huge. So that's why so in our case, to minimize the on-chain storage cost, we hash both of the value and the keys before we start it here. So that's why you can notice, right? We don't call it a hash map, we call it a hashed map, because both the key and the values are hashed before you before it is stored on chain. Okay. So this hash map also, you not only you can use it in the contract context, basically meaning under methods, right? So we have seen before. So anything in a contract that's under methods decorator, there's going to be end up on chain. Right? We call it on chain context. So hash map you can use both ways. Right? You can either use in methods, meaning in the on chain context, but later on we are also going to show you can also be used in the off chain contract because that's how you construct the map and then pass it. Eventually, use this off chain version to construct the spending transaction. Okay. So
with a hash map, you can obviously never retrieve the value, yeah? You can just check that it exists or something.
Yes. So because it's a hash map, so it's like the Bitcoin model. You're not just returning. For example, I think this can give you some idea. So you can have set, has, delete, all this is almost as a regional map, right? But you cannot get because the value is not there.
Yeah.
You can also check whether you can get it. The way you call this API is say, hey, if I want to check this key and this value, does this key map to this value? You can only check this. Yeah. Okay, because it's the regional value is not in the contract itself. Okay, make sense?
Yep.
You can check it. Yeah. So the way you can eventually get this value is so-called that's why we need the off-chain part, because the off-chain part you pretty much have the raw data, regional values, and then when you call this, right? So you can always use in the off-chain part you can use get, because you pretty much also had not only you have the hash version, but also you also have the original value as well, because it's kept off-chain. On-chain version, you don't have this, but off-chain you can use get. Okay, that's the biggest difference. So that's how you actually get it, and then you can pass it. For example, if you have a key, and you can get back the value off-chain, and then when you call the methods, you can just say, hey, you can pass the value here. Once you get this version here, value, you can pass it here. And then in this map, you can just say, hey, is this value corresponding to this key? If it's good, it's good, right? So this is almost like a very typical way. I think it's how the programming Bitcoin smart contract can be different from, let's say, you're writing some regular JavaScript or Python code. You're not just directly computing. You're actually you're checking it. You're validating. Make sense here a little bit?
Yep.
It's a little bit different. Yeah. So yeah, that's pretty much the only big difference. So in the on-chain, because the hash value is stored instead of original value, so you can only check whether this key and value matches. Basically, it says in this map, does this key match, give me this value? Okay, if only returns true if it is yes. Okay, but you cannot just get a value for a key because it's not there. Okay, at least in the on-chain map. Okay, so this is is very typical to just like a regular hash table kind of thing. So you can set it. It's here, set, no problem. You can pass key and value in the original format. That's okay. And you can check whether a key exists. You can delete the keys, and you can clear the whole thing. You can also tell how many entries it has. Okay. Yeah, it has some other, so-called, constraints. So just be careful not to use it in non-public methods, because this thing is always going to be passed It's going to get the regional values from off-chain and then pass it in by calling the public method. So just pay attention to all these bullet points. I think most often you will just declare one at the top level as a property, and then initialize it. Most likely to be empty at the beginning, and then because of state, you just keep updating it. So the way you can get to the latest, I think this also maybe interesting if you are using what's on chain. So maybe later on we can have some kind of API that can fetch, give me the latest transaction. I'm going to tell you what's the latest regional map, because you can every transaction, right? You update the map, so you kind of you have the regional value, you have delta, right? Every time it's almost like a state transaction. Yeah. So you can, because in each transaction you update, for example, one key, right? So how to get the regional map? You pretty much replay all the transactions. So that's how you keep track of this off-chain. Once you have this off-chain, you can always pass the correct value into the contract, and which the contract can get, right? Okay. Yeah, so this is a little bit of a different, I would say, from let's say JavaScript or Python, math, or C++, unordered math. So that's a major difference. Basically, the key value, the raw value is not there. So the only thing you have to say is, if you want to get a key value, you have to pass the value itself, and then the contract can verify this key is the value itself. Okay. So in this way, for example, your value is like, I don't know, 1 megabyte, right? But on chain, in the map itself, you only store the hash. So you don't have to spend, even if it's even megabytes, it doesn't matter. It only stores the key and the value in the contract itself, a hash of them. Okay, that's compressed. You can think about almost like compression. Okay. And there's some constraint when you use it, because it's this kind of special hash map. So just watch the bullet points, and most likely you end up writing something like this. So you don't have to track all of them. Unless you have a very special scenario, this will be almost always the way you write it. Okay. So in our examples, we also have provided quite a few examples for if you're dealing with a hash map. So we have a hash map of quite a few examples here we put. So why is you just use it? You are not putting a state. It's not a state variable. So we have some examples here. You can check, using pretty much all the standard APIs from the map. So you can check. Also, the way how you put in a map, right? It's a map. You use it as a property. It's here, and then you can, do all kind of updates, right? You can insert, delete, update. Yeah, pretty much like the usual way you do it. So you can check these examples how you use it in practice. Also have some tests. The tests use off-chain version of it to construct the key value, so you can pass it in the on-chain part. So you also have tests, right? And you can also check, you come through with all the tests. So in the test part, you're going to have the off-chain version. And then off-chain version has every regional value, so you can check and verify it. Okay. Any question? I think this is a little bit of a different from traditional hash map. Is understandable so far? Is okay? Okay. I'll take that as a yes.
Yeah.
Okay, no problem. So since we have this hash map, of course, right? There's people always almost ask, oh, what about set, right? Because if you have a hash table, you usually have a hash set. So basically the set can be, you can think about, it's just a special hash map, right? Because the key is equal to the value. So that's the only difference. You can almost think about it as a map, but when you insert, it's a set, right? So basically you do all the, you can insert into it. So basically that's, if the value already exists, it will not, right? It will not do it because the set, each element in the set is unique, right? So basically this also check, check the membership, whether it's there. So this all the, almost the same thing with the hash map, except you can treat it, there's only value, there's no key, because the key is the same as a value. This is often used to check that something duplicate, right? For example, you may have a voting contract, right? So you have certain list of candidates, and people can go there, and if they can vote, right? But for example, usually you don't want one person, right? I mean, if we can use a public key or Bitcoin address, as a representation, you don't want one key to vote twice, right? In this case, it's a good use case, right? You can use this hash set saying, hey, if you have already voted, yeah, you cannot vote it again. Sorry. So for example, right, this is the usually used to check the set membership. So that's make sure there's no duplicate there. Okay. So again, you also have the on-chain and off-chain part. Pretty much almost the same with the hash map. So you can see here. And yeah, this is the most often used, I would say, you're going to use pretty much other than struct, customer defined types, and fixed arrays. This hash map or even hash set is also, often used. It's a typical data structure you're going to use it often. Okay. I think the last part is also very easy, because we have some constants, especially in terms of when you're parsing some transaction, so we just hard code all of them just so you can use it easily. You don't have to remember. For example, out point, right? So when you are parsing a transaction in the input, you have the out point, right? Then you have the script part. So out point is pretty much the transaction ID plus the output index. So transaction ID is a hash of the transaction, so it's 32 bytes, and the value part is like Satoshi part. It's always 4 bytes, so it's 36. I think, yeah, you don't have to use this, but it's just because it's used so often. So anyway, we put it in a constant library. So if you don't want to hard code it or even write your own constants, you can check whether it's already here. Okay. For example, our public key length, we are talking about compress, right? So it's 32 plus 1. 1 is a sign, 1 is a parity byte. So it's already going to 33. So I mean, this is handy, but you don't always, you can also write your own constant. That's no problem. Okay. All right, I think that's for all I have today. I think it's just a lot of handy functions you're going to use. I think of a lot if you have any kind of a non-trivial smart contract, and we also put the usage in all kinds of the examples. So you can also, if you don't want to go through all this kind of like very comprehensive documentation, you can also just check. You don't want to read this, just we all have all the examples for each of them, so you can just come here, pretty much look at the examples and copy paste, and then modify them if you want, depending on a style. Okay. All right, sounds good. Any other comments, questions?
No,
it's good.
All good.
Okay, yeah. Okay, good too. Okay, I'm glad you stayed till the end. So, all right, happy to speak, and see you all next week. Then have a good one.
Yeah, thanks
everybody.
a lot.
Okay,
Bye.
thank you. Bye.
Cheers. Bye.
Cheers. Bye bye.